Okay, the curve C has equation y equals x to the power 4 plus x plus 1. Find the equation of the tangent to C at the point 1, 3. So suppose, let's just draw a sketch of a curve, okay? It doesn't matter what it looks like, but we've got a little bit of a curve here, and I've got a point on the curve. They say in the coordinate is 1, 3, okay? And we want the equation of the tangent. So remember, a tangent is a straight line that touches the curve, okay, at that point there. So it's got the same gradient, the tangent has got the same gradient as the curve at that point there, hence why it's touching it, okay. And we need the equation. So remember, for the equation of a straight line, okay, you need to use the formula y minus y1 equals mx minus x1. And what's key for this, the key ingredients are determining the gradient, okay? And also we need a point that the line goes through for my x1, y1. Well, in this case, we've got the point, x1, y1. We've got a coordinate here that the line goes through. We just need to work out the gradient. And just remember then, of course, the gradient for this line, okay, will have the same gradient as the curve where it touches at the point 1, 3. It'll have the same slope. Now we can determine the gradient of the curve at that point by using differentiation. So my curve equation is given to us. So we could differentiate. We can do dy by dx. And of course, in this case, you bring the power down, reduce the power by 1. X just becomes 1. And then 1 then differentiate the constant becomes 0. So this is the derivative. This is what dy by dx is. Now that's what we call, of course, the gradient function. Okay, it's a function because we can use it to work out the gradient at any point on that curve. I'm interested at the point they've given us 1, 3. And of course, at that point, x is equal to 1. So we'll sub it in to this gradient function, and it comes out to be 5. What you should be writing then, you should be annotating this and say, look, this is the gradient of the tangent, okay? Because you essentially then, you're answering your question, aren't you? You basically were determining that the gradient of my tangent here is what we've determined here to be 5. So I can simply then plug it into that formula. So y minus y1, so remember y1 would be 3. And then the gradient is 5, and then my x1 works out to be 1, that coordinate there. Okay, so we've got the equation then of the tangent. I would sort of annotate that as well to say exactly what I'm working out here. Okay, we'll simplify that to make it a bit nicer. So we'll expand the bracket, and then maybe we could write it like this. So we take that negative 3 over, and you end up with a simplified version of my equation of my tangent there. Y equals 5x minus 2.